Number 6, that is a weird numerator. So we'll worry about that in a minute. Again, organize my thoughts here even before I get started. Domain would be x can't be 0. Whatever's going on in the top, I don't know if you want to rewrite it like that, maybe, because that might help us factor it. 1 minus 2x and 1 plus 2x. And I need to factor it to know if anything cancels. So I don't need to factor to see that the domain is x can't be 0, but holes are things that canceled, so I need to factor it to see if things will cancel. Nothing does, which means that x equals 0 is a vertical asymptote. It's also a double root, or a double asymptote, if that's such a thing. And we'll see later if we can figure out what that means. You don't have to know that or know what it means, but when we get to the end, maybe some of you will recognize what happens differently about this asymptote compared to normal. All right. Oh, I'm not writing it this time. We've done it enough. Bobo boss eats DC. This one is a... Which one is it? Show me with your fingers. Is it 1, 2, or 3? Which case is it? Bobo bots or eats DC? Not very many people bold enough to say a lot of this. Nobody look at my answer. This? Right? Eats DC. Exponents are the same. I guess maybe it depends on which way you're numbering it. If Bobo is 1 and bots is 2, then it's 3 eats DC because the exponents are the same, because they're both x squared. So when we divide the coefficients, we get -4, which means there's no slant because there's always one or the other, never both. Y-intercepts would be where x is 0. So if I plug in 0, I get 0 plus 1 over 0. Whoops, I can't divide by 0, so there aren't any y-intercepts. X-intercepts are where y is 0. And again, the only thing that makes a fraction 0 is the top. So I'll set both of the numerator factors to 0. So -2x equals -1. So x equals 1/2. And the other one would be -1/2. So I'm going to be, I almost said lazy, but I'll say efficient. It's a much better word than lazy. I'm going to be efficient and just say plus or minus 1/2. I mean, if you're lazy but still getting the job done, that's being efficient. All right, vertical asymptote at x equals 0. Horizontal asymptote at y equals -4. X-intercepts at plus and minus 1/2. We haven't done very many that look like that. Technically, I have enough because I got 1 point per branch, but that looks new and different. So I'm going to do a table of values to maybe confirm what I think is happening here. So I'm going to pick maybe not 1, maybe x equals 2. See what happens there. Again, you start getting away from the axis and you might not get a nice answer. So plug in 2. That becomes -15 over 4. -15 over 4. That's almost to -4. Right? Because -16 over 4 would be -4. So I'm going to go almost to negative 4. And by the way, because x is always squared, it wouldn't matter which x we plugged in, plus or minus 2. We'd be down at almost negative 4. So I think that confirms what I thought was going to happen. Looks something like this. All right, so we're done. We're good. But this double asymptote thing, anybody want to offer a guess on how that affected the graph? How is that graph different than every other one we've done so far? Okay? It's not corners. It's not opposite. I'm going to use a word that we've used with doubles before, and that is it didn't alternate. Usually across an asymptote it alternates. Like all the other ones, if one's going up, the other side's going down. Which is basically what you said. Well, across a double root, it doesn't alternate. That's the same rule that it goes for with when we were shading. If there's a double root, it doesn't alternate. You don't have to know that, right? I mean, it took care of itself. But that's one of those things that if it's in the back of your mind and it happens, you're like, oh yeah, I know why that happens. I'm comfortable with how that looks. So that's what a double root does. Similar to what it does on shading a number line. All right, so that's number 6.